Hello, Peter.
Hi, Anna.
I have a few questions for you that I would like to ask. The first is, why do you think, if you think, that BIM is important nowadays in architecture?
Well, it's I suppose, the lifeblood of architecture in some ways. Architects have always managed information about buildings. That's what we do, is we design a building, we try and put information on paper or in a computer about what it is we want, how we want it to look, how to build that, and how to take care of it. And BIM is the first time that we've been able to do that in a codified semantic way. That I suppose you could always say that we've always used lines that represent walls, so we've always had coding done, but this is explicit now. And the fact is that the demands of architecture are so much higher. It's not just that it needs to be built and not leak. It needs to be built and not leak and be CO2 efficient and be resource efficient and be energy efficient and have a warranty of 20 years and all of these other things, the information that needs to be there for those to happen. And so BIM is basically just the codex of being able to describe buildings properly.
Mm-hmm. And do you think the industry have changed in the sense that now they are shifting towards BIM, or are we at the beginning? Are we at the end of this? Or
I think we're at the beginning, in that it's not clear to everyone who's involved why BIM is a good idea. And for a lot of the people who are involved in either constructing or designing buildings, it seems like extra work. Because we've always built buildings a different way. We just use paper and pencil or AutoCAD and lines on drawings. And we've been able to build buildings that don't leak, so why do we have to have BIM? And it sounds like just one more thing to do. But there are some things like being able to go file to factory. There are some things like being able to make sure that we don't have collisions on building sites. There are some things like being able to verify what kinds of materials are in buildings, that BIM, only having something like BIM is going to do for us. And even if you said, okay, we'll forget the industry foundation classes and we'll just try and codify this again and use something else other than BIM, it will still end up looking like BIM. It will still be something that describes walls and floors and roofs and windows, and then be able to attach the information to those. And so it's at the beginning. And maybe a second thing to say is that construction is one of the most conservative industries in the world. And it's not only conservative, it's moves slowly, takes a long time to have a building built, and it's regionally cut up into different sectors. And that's partially nationally and partially just that construction is a local activity that usually happens with local contractors and local people. There aren't very many multinational construction companies. There are national champions, but it's very difficult to move across borders with different rules, different regulations, different suppliers, different ways that architecture is done, like how does the actual designers and so work. And so that conservatism means that anything, whether it's a new building technology or a new information technology, is going to be slow in its uptake. Mm-hmm. There's a long way to go.
Okay, and a lot of architects who I speak with says that architecture is about creativity, but BIM gives a framework where you have borders, and you may be cannot be that creative as without these technologies. What do you say for that issue?
I think that it's a myth that architects have some kind of specialty about creativity. Like if you want to come up with a new research topic, if you want to solve a mathematical problem, if you want to be a success, create new medicines, you have to be creative. Creativity is about how to solve a problem that's not obvious how to solve it. That's what creativity is. And whether the problem is designing a building or creating a new medicine, there's not a scale of creativity. There's just you are creative and you can find a new solution or not. And so to say that BIM stifles creativity is a bit of a cop-out, I think. It's not a real answer. And in fact, perhaps what people are talking about is the imprecision that you have if you're just waving your arms and talking about a space and light and whatever. You can have an idea in your head without it being cemented down, perfectly described. And what BIM will want to do is, of course, get to that exactitude. That's what computers love to do. They love to be exact. And so for architects that are reluctant to commit to that, I don't know if it's steel or concrete. I don't know if it's got a curvature of 21 meters or 20 meters radius. I don't know yet. It's then difficult to work with something that wants to know whether it's 20 or 21, which isn't. And so either you find ways to work with that, but then you also have to embrace it at some point, because you do need to know those things. You do need to know at what radius it is, because if you're going to order it and have it built, then those people need to know exactly what you want.
Mm-hmm. And what do you think about that? When should students or architects learn about BIM? In the university, or during their university years, or after that? Because I have met with some architects who say, no, during the university it's not worthy, and after that they just go in an office and right away they will learn all this BIM thing. But there's not the other side of the architects who say, no, during the university years it is really fundamental that from the beginning they start to learn that there's the computers, how can they use these? So what do you think about this question?
My answer is that you should, when you enter the university, your computer has to be a professional tool. If you can go through high school by maybe writing some papers and some exams, but when you start to study architecture, your computer is going to be your tool. And if you have a set of tools, you keep them sharp. And so you have to be using your computer sharply. And that means knowing what BIM is. That means knowing when you start to design a building that the information should have as long a longevity as possible. And you shouldn't try and do things in a way that are either sloppy or can't allow that information to be used by other people. And BIM is not necessarily a software. It's not Revit. It's not ArchiCAD. BIM is a mentality about formulating and codifying your building properly, so that a wall is identified as a wall and not as a door. If you describe the building properly, then you can do so much with it, in terms of animation, in terms of automation, in terms of 3D manufacturing, all sorts of things. But that only works if you've been precise about your data. And so I think you need to learn not about BIM per se, it's not about learning Revit or necessarily, but just having that mindset that, okay, I'm going to be the architect, which means I'm going to be responsible for the information about this building, because it's my building, it's my design, or it's our design. It's also fine, but that means taking authorship and taking responsibility for the information, and not just, oh, well, I did it in SketchUp, or I did it in PowerPoint, or I did it in some software that then no one really can understand how to use that data. And if the data doesn't have a longevity, then you're not being a good professional.
Mm-hmm. And does this mean that architects should learn how to program?
Some should. Or I'll put it a different way. If you're an architect and you have an idea about something, and something is going to be round, and your design methodology is a sculptural one, I'll call it, then you don't need to know how to program. You just need to know how to translate some kind of instruction set for someone else so that it's done the way you want it. Whether that's a NURB surface or whether it's done in Excel is kind of up to you. But you still need to describe that curved surface somehow so that people can do something, build it for you. If, however, you are trying to have measurable performance of the building based on some criteria that you could define, then you might want to learn how to script or program, because that will give you the ability to say, this data should affect this design, or I need to test this against this. And that testing is either a direct link so that the data is driving the form or the shape or arrangement of something, or I'm able to push a button and do a simulation that can tell me about that and tell me how it's doing in relation to that, whether it's temperature, heat, or whatever. And so the worst thing would be that you want to pursue a kind of parametric or responsive design, but not know how to do that yourself. If you always have to run to a programmer and say, I need you to program this, then there's a weak link there in your ability to be able to control your design. And that's sort of, if I have a message for anyone, it's like, if you're the architect, you have to be in charge of you have to have ownership of the data. Otherwise, it's not your building anymore.
And could you share your vision that how in 10 or 20 years architecture is going to look like?
Probably a lot like it does right now. Like, all of the buildings that you see are still going to exist in 10 to 20 years, unless there's some catastrophe, like a major hurricane or a bomb or a flood of the Netherlands. Most of the buildings that you see will still exist in one form or another. They might be renovated or whatever. So, first of all, architecture is not going to look much different. Like, 95% of the buildings, or 99% of the buildings are still going to be there. There are going to be a couple more. But construction takes a long time. Like, if you decided right now that you wanted to build a new high-rise in Amsterdam or in Rotterdam, it's going to be 8 years till anyone can move in there. Like, if you decide today, it's going to be 8 years. So, in 2030, anything that's decided after 2022 is not going to be happening yet. So that's the first thing. The second, I think, though, is that what's going to happen more and more is that this process of automation of our design, of our assembly, of the use of buildings will continue. And we'll continue to experiment and try and put more and more automation, almost to the point where you could call some things intelligent. But that's not going to happen with the speed that you might think, because we haven't wired our buildings. Like, if you wanted to turn this building here in Eindhoven into an artificial intelligent run building, well, you can't just do that. There's no way to turn the lights on and off except to go physically to the switch. So either you've got a robot that's walking around pushing all the buttons, turning the lights on and off, or you have to rewire all of the buildings in order to allow that, and allow a two-way wire, allow the light to say, hey, I'm on, and the artificial intelligence to say, well, why don't you turn yourself off? And that's a lot of infrastructure that doesn't exist. So I think slowly you'll see that we'll have some new buildings or maybe some renovations where we can try and test this out. But for the most part, building permits, we're still going to have. Construction sites we're still going to have. I dream of a dust-free, water-free building site, but that's still going to be a while away. Unless you look at sort of maybe housing in some parts of the world might become, let's say, commoditized, where you have prefab things where you can basically pick out of a catalog. But if you're talking about any building of substantial size, it's still going to be built by people on the site with probably a lot of concrete pouring and a lot of cranes lifting stuff and moving them and adjusting them and hooking them together.
And one last question. If you would have a magic wand that you could make any kind of technology, any kind of skills for yourself or for architecture by itself, what would it be? Maybe to have less fear. I think that even though architects are creative and have bold ideas, I think that they're in some ways scared of new technologies. They're scared of something like BIM,
And I think that actually architects are in a really great position because we've been trained to solve problems when there's not complete information. We can solve problems when things aren't structured, and that's a huge asset. It's a real strong point of resilience, actually, to be able to not worry about having all the data and it all being set up properly, like maybe an engineer might need to do calculations. And that kind of resilience means that we don't have to be afraid of any new technologies. We'll just absorb them and continue to do what we do, which is trying to make the world a better place. And so, yeah, my magic wand would be for more courage or less fear.
Okay, thank you for the interview.
You're welcome. Thank you, Ed.